So far, we have discussed the Fourier transform between time and frequency. Now we extend the idea to spatial variables. First, let us consider the one-dimensional case. We define the Fourier transform from the coordinate x to Wavenumber space k sub x. So, a pair of Fourier transforms between space and Wavenumber domains is given by those formulas. The first is the forward transform. If we have a function f of x which may represent physical quantities, such as electric fields or temperature. By this formula, a spatial waveform can be decomposed into sinusoidal components with different wave numbers. On the other hand, from those sinusoidal functions, we can construct arbitrary spatial distribution. This corresponds to the inverse transform. Here, x is the position variable. K sub x is called the spatial frequency, or wave number. Essentially, this transform is the same as the time frequency Fourier transform as token earlier. The difference is that the time is a one-dimensional variable, but the space is generally three-dimensional. Therefore, we can extend this idea to 3 dimensions. Consider a function f of x, y, z. We first take the Fourier transform with respect to x. The result is the function of k sub x, y, and z. Then with respect to y, and the result is a function of k sub x, k sub y, and z. And finally, with respect to z, we obtain a function of 3-dimensional wave numbers. By combining these, we obtain the 3-dimensional transform. This can be written as a triple integral of f of x, y, z times exponential of jkxx plus kyy plus kz. We introduce the wave vector k, which is defined as kx in the x direction, ky in the y direction, and kz in the z direction. Similarly, we define the position vector r. Then the exponential term can be written compactly using the inner product, k dot r. The inverse transform is also expressed as a triple integral with exponential of minus jk dot r. In this way, the Fourier transform in 3 dimensions provides a powerful tool to analyze spatial fields. This is widely used in electromagnetics, wave propagation, and many other fields.